Okay, so we're gonna do some more L'Hopital's rule, but they're for different indeterminate forms, okay? The first one we're gonna talk about is called an indeterminate product. Now, we know that infinity times anything should be infinity, 0 times anything should be 0, but how about infinity times 0? Which one, in a sense, this is just an analogy, which one is more powerful? Do you take infinity and multiply by 0 and get infinity? Or do you take infinity multiplied by 0 and get 0? Okay? So this is an indeterminate product because we can't decide which one it is. So your goal here is if you get an indeterminate product, or when we talk about indeterminate differences or indeterminate powers, your goal is to somehow get 0 over 0 or infinity over infinity. Once you can do that, then you apply L'Hopital's rule. So here's our first example. Oh, actually, let me get rid of this so we have more room. So limit as x goes to, where's our first example? Goes to infinity of x squared, or actually x cubed, e to the negative x squared. Alright, now if I were to plug infinity into here, this would be infinity cubed times e to the negative infinity squared. This part's infinity times this part is 0. So we have an indeterminate product. However, this one's fairly easy. I could rewrite e to the negative x squared. I could put it on the bottom of the fraction. So now I get infinity cubed over e to the infinity squared, which is just infinity over infinity. Now that it's in the correct form, I can apply L'Hopital's rule. I cannot apply L'Hopital's rule up to here on this one yet, because L'Hopital's rule is only defined for infinity over infinity or 0 over 0. So now that I have this equaling infinity over infinity, let me go ahead and apply L'Hopital's rule. So this is the same thing as limit as x goes to infinity. Well, the derivative of the numerator is 3x squared. The derivative of the denominator is e to the x squared, but now I gotta take the derivative of the inside. I gotta take the derivative of x squared, which is 2x. If you notice, the x here in the one on top cancel. So I'll write it over here. This is the limit as x goes to infinity of 3 divided by 2 e to the x squared. Now if I go ahead and plug infinity, oh, I forgot an x on top. Now if I go ahead and plug infinity into here, I get 3 times infinity, which is infinity, e to the infinity, which is infinity. So I have to apply L'Hopital's rule one more time. So this is limit as x goes to infinity. The derivative of the numerator is just 3. The derivative of the denominator, we already did that. It was 2x, it's right here, 2x e to the x squared. So when I take the derivative of that, I should get this piece multiplied by another 2. So it would be 4x e to the x squared. But now when I plug infinity into here, I get 3 divided by 4 times infinity, e to the infinity, which is 1 over infinity. Or in other words, this limit, let me go ahead and rewrite it, is 1 over infinity, which is equal to 0. So as you see, it's exactly the same process as the previous examples. However, You just have to algebraically manipulate it a little bit at the beginning to get it in the correct form. So let's go ahead and do another one. Limit as x goes to, let's see, I think it should be positive infinity. I have a negative infinity in there. It should be a positive infinity. Or actually, no, it works with the negative infinity. There we go. Let's see. X ln of 1 minus 1 over x. If I plug negative infinity into there, times the ln of 1 minus 1 over negative infinity. Well, this is still negative infinity times ln of 1. The reason why it's 1 is because 1 divided by infinity, it doesn't matter whether it's plus or minus infinity, 1 divided by infinity is 0 in a limiting sense. So 1 minus 0 is just 1. ln of 1 is 0. So we get negative infinity times 0. So we have a problem here. Okay? What we have to do is we have to rewrite this such that when I take this limit, I'm going to get infinity over infinity or 0 over 0. Okay, let me write that a little better. X goes to negative infinity. So what I'm going to do is I'm going to rewrite this as the limit as x goes to negative infinity of ln times 1 minus 1 over x divided by 1 over x. If you think about how I would simplify this, I would multiply the numerator by the reciprocal of the denominator, and you can see I end up right back where I started, okay? Like if that cancels right there, you could see x over 1, x over 1. You end up with what you started with. So this expression here is equivalent to this expression up here. Now let's go ahead and find the limit. Well, you know this part is going to come out to be the ln of 1 divided by 1 over x. This is equal to 0 over, this is 1 over infinity, which we just talked about as 0. Now I have this limit in the correct form. Because when I evaluated the limit, I got 0 over 0. Since I have 0 over 0, I could apply L'Hopital's rule. So I'm going to rewrite it over here. Limit as x goes to negative infinity of ln 1 minus 1 over x divided by 1 over x.